Alright guys, we're going to do day 1 of your sheet, and let's go ahead and get this thing going. Alright, so it says name the point of concurrency and tell why. Well, the point of concurrency is this center point right here. That's our point of concurrency, or where the center of the triangle is at. So if you notice, we're going to look at the sides here, and these marks tell us something. So it's telling me that this point right here is a midpoint. If these 2 points are the same, those lengths are the same, then this is also a midpoint. And right here is a midpoint also, because these 2 sides are the same marks. So if all of these are midpoints, my next thing to look at is how is this red line connecting from the midpoint to the other side. And if you see, it's connecting from the midpoint to the vertex of the other side. And so these lines are called medians. That's a median. So since these are medians, all of them do the same thing, then this is called a centroid. This is a centroid. Okay, and it's because the center point is the intersection of medians. All right, that is why. Okay, so let's go here. It says name the point of concurrency and tell why. All right, so here's my center point. That's my point of concurrency. And if you notice, I have some marks on angles now. I have angles that are being split in half. So these red lines are called angle bisectors. These red lines are called angle bisectors. So this point of concurrency that's created by angle bisectors is called the end center. That's called an end center. So because that is called an end center, and it's because it is created by angle bisectors. I got that point of concurrency where all of these lines intersect at, and they're angle bisectors, so that's called an end center. All right, let's keep this show going. Next, it says name the point of concurrency and tell why. Well, let's look at what's going on. I see a circle on the outside, but let's dig into it a little more. So here's my point of concurrency, and I noticed here that I have another midpoint. That's the midpoint. And I noticed that this red line right here is crossing this. Let me give you some colors. This purple line is being crossed by this red line at a 90-degree angle. So I'm going through a midpoint and I'm being crossed by a 90-degree angle. And if you look, that is happening with all of these lines. So these line segments rather. So this is called a circumcenter. And the circumcenter normally has the circle on the outside of it. And I'm going to tell you what that means too. So the circumcenter, because the segments are perpendicular bisectors. They're perpendicular bisectors. These, well, let me highlight them. These yellow lines right here, they go through the midpoint of the line segment, and they cross that line segment at a 90-degree angle. There is also something else that's interesting about the circumcenter. This center right here is equidistant from its vertices. That's why we draw a circle on the outside. Let's do a different color. Okay, so the circumcenter is equidistant from the vertices. Now what I mean by vertices is the vertices of the triangle right here. So this point right here is equidistant from this point, this point, this point. So what that means is from here to here is a radii. These are called radii, and they're all going to be the same length. So if this is 5, that's 5, and that's 5. And the circumcenter normally has a circle on the outside of it. Okay, so this next one, it says name the point of concurrency and why. So if we look at F right here, we know that this segment is perpendicular. Now it's not bisecting AB. FC is not bisecting AB. But what I do notice is that this line here, well, I'm going to put it in purple, this line here is going from this side and it's connecting to the vertex of the opposite side. And it's doing that with all of the sides. So it's crossing at a 90-degree angle and it's connected with the vertex of the opposite sides. So this here is called an altitude. So if that's an altitude where they meet at or they intersect at, it's called an orthocenter. And there's a way you can remember this. Ortho means 90-degree too. That's an orthocenter. And we're going to say because the segments are altitudes. The segments are altitudes. Okay, let's keep going. All right, well, that's it, babies. Okay, see you guys on tomorrow. Bye.